Hello, yeah, I've been sent one of these Lidl battery chargers. Do you remember, if you look at the other videos, we did a modification because of the charging issue we had. Well, mine, someone sent me this and said mine's packed up as well, so I thought I'd have a really quick look at it, because it might be something simple that everyone can do to fix theirs. It's got a display in this one. Mine hasn't got the display, mine's just got this mode button and a bunch of LEDs, so I'm guessing this is either an older, more advanced version or a more expensive version. Nonetheless, it's not working, and he said he powered it up, nothing was coming on. I can confirm that's absolutely true, because nothing is coming on. So yeah, I'm just going to whip it apart. There's you can hear the spark on the switch, so there's current rushing into the reservoir capacitor in there. There's a little pulse of current going in, because you can hear it sparking on the switch. So it looks like either the power supply is not working or the micro is not booting up. There's no power light, which may be driven by the micro, but might just be a resistor and a diode, and doesn't come on, so indicates the power supply might be a bit iffy. So I'm just going to whip the screws out, I'm not going to waste your time, and I'll be back with the disassembled unit and we'll poke about for a minute or two. So here she blows, she's out of the case. Display, obviously, no points there. Push button, indicator LEDs, power supply, and then control electronics. Now it looks like that clips on there, so this is not plugged in at the moment, hasn't been plugged in for some time. If you open one of these, the capacitor in here will hold the charge for a long time, so you could get a shock even though it's not plugged in. And to mitigate or to remove the possibility of a shock, you need to, there's a reservoir capacitor under here, look, this one, that's the one that charges up to about 360 volts. You need to just charge that sucker to make sure that you don't get a shock. So unplug it completely from the mains and then just short that out. This one's already got no charge in it. If you've got a multimeter, you can just check it with the multimeter to make sure there's no voltage lurking in there, which is going to spoil your day, or at least make you jump, wake you up with a start probably, depending how weak your heart is. So let's have a quick look at what we've got here. So to probe with a probe. Here we are. So right, mains coming in here. Rectifier diode here, power supply control chip here, and some dropper resistors here. A resistor there going to the midpoint of this filter. Underneath there is a common mode rejection filter. Yeah, there's a filter choke under there, a common mode rejection choke. It's to stop the switching spikes going back down the mains and radiating out this cable, interfering with radios and such like. It's called to stop the conducted signals. It's to do with the immunity. So what have we got? We've got the chip, reservoir capacitor, we've got 100 ohm resistor, so 100 ohms, that's got some power going through it, otherwise it, no sorry, 10 ohm resistor, clearly got some power going to it. Got a small diode, a Zener diode. So what there is on this board are a bunch of resistors down here, I think, which provide the bootstrap current, the voltage for this chip, the low voltage DC for this chip to fire up and start working. And usually on these power supplies, once this is fired up and started working, there's a reservoir capacitor on the low voltage side, sometimes 12 to 40 volts, 37 volts or something like that, and the capacitor holds enough chance to get this going to start switching. When it starts switching, there's a tapping off the transformer under here, which isolates the user side from the main side, and there's an additional winding on here which then takes over, so it kicks it into life and enough power comes down through this winding, through there, through the 10 ohm resistor, presumably through one of these diodes. That's the Zener there, I think, the size of it, through that diode, and then when the thing is running, this transformer, resistor, diode provide the DC low voltage supply for this chip. Before it's running, these resistors drop the mains, the capacitor charges up slowly, maybe a couple of seconds. This then detects that the DC voltage is usable. It fires up into life, it starts to switch and starts to produce power, a flux in the transformer, but as it starts to do that, it's consuming the power that's in this reservoir capacitor. There's a small reservoir capacitor under there, and as it starts to consume that power from that capacitor, that capacitor obviously will start, the voltage will start to drop, but then the flux in the transformer will cause a voltage in the winding, which will then go through that resistor, through that diode, and then from that point forward this will support the low voltage DC directly from the switching operation, and regulated by this diode to stop that going too high. Clearly if that resistor wasn't there then, and that Zener was there, it's going to put a lot of stress on that Zener, so switching poles through there to hold that voltage up. Now if this path is missing or not working, the thing won't fire up. If you've got no low voltage DC bootstrap supply for this, the initial supply, it won't fire up and it won't work. And if you've got no AC bootstrap supply coming through, then usually they start up and go down, they keep kicking into life. The capacitor charges up slowly through this resistor network, the voltage comes up to a point where this detects I've got some voltage. Then I find myself into life, and then my voltage falls away, and there's nothing, the cavalry isn't coming through here to hold the voltage up to keep this working. So you often get this kind of pulsing thing going on. So let's power it up and see what we've got, shall we? I'll just wheel that in there. Can you see that? No, you can't. Well, you should be able to. I'll move that forward like that. Move that like that. So you can see the voltage. We're set to, what are we set to? 1000 volts. Turn her on. Right, no lights, still not working, so it wasn't probably a bad connection. Reservoir capacitor voltage coming up. This is the rectified mains. Mains, be careful. There you go, got 300. This is turned down. I'm on a variac at the moment. If I turn that up to there, that's 200. There you go, 308 volts. So that's enough to kick it into life. What have we got across our Zener? This should be our low voltage bootstrap supply coming across these resistors. What have we got there? Let's put that on to 20 volts. Alright, we've got 0.5 volts. So there's no voltage coming through to the DC side of this chip. So either this chip is shorted or there's something wrong with the supply circuitry. So let's poke about further. So I'm just going to short this reservoir capacitor out, as I mentioned. Otherwise I could get a shock poking around here. Alright, safe. Just check the voltage on that again. Well, that didn't make contact then. You have to be careful and make sure that you actually did make contact when you were shorting it out. There you go. I never get used to that, you know. I never get used to it. It makes me jump. Right, so I'm going to go on to continuity now. This is diode forward voltage drop, diode continuity. So it's passing a current between these two probes, forward voltage dropping through there, and it'll beep on a dead short, and this display is reading the forward voltage drop. So if you put a diode in there, you can actually measure it, the forward voltage drop. So let's measure across this. So the Zener's not, the Zener's reverse bias, and it's giving me 720 millivolts, which is probably about right for the Zener. So that would indicate the Zener probably isn't shorted. Now this, we reckon this is a rectified diode. 55 millivolts one way. 55 millivolts. So that rectified diode seems to be a potential candidate for being shorted. So let's just check that to the 0 volts, which is there. 599, which is a Zener. Yeah, well, my guess would be that that diode is short. So let's have a quick turn the hot air gun on. Put some flux on it. It's Kingbo flux, just surface melt flux. Check we're turned off. Get the hot air gun. There we go. You can see the fending components here. Just put some hot air on it. Anytime you're ready. Okay, so diode is removed, noting that the band on the diode was facing this direction on the board. Yeah, diode is shorted. Actually it's faulty, it's cracked by the look of it. It's got a crack in it. Now it's open circuit. Can't win, can you? Short 1 minute, open circuit the next. But it's clearly a sick diode, 54 millivolts across it, so yeah. A diode should normally, a Schottky guide would be about 200 millivolts, and an ordinary silicon planar diode would be about 600 milliamps. So that's the problem. So I've got to find a diode to go across there. I think that will probably cure it. In fact, if I turn it on now, the bootstrap supply might just fire it up without the actual auxiliary supply. So let's try that, shall we? See what happens. See what happens. Ah, there you go. Look, it's working. Yeah, so it's running off the bootstrap supply at the moment. So now if we have a look at that DC voltage on there, coming from bootstrapping, this is across this Zenny, you'll see it'll be going all over the place. Yeah, it's running at, it's actually running, it's managed to sustain 10 volts, but that's pretty low. I've never seen one as low as that. And that is just power coming from the bootstrap. So if I turn the input voltage down slightly, yeah, it's maintaining a reasonable 10 volts. But it should be something like 20, I should think, would have thought. So I'm going to find a diode and I'll be back shortly. Okay, so we've got, I've just pinched a diode off a board. This is a Schottky diode, a 2 amp diode at 50 volts, which would be fine for this. Clearly it's a much beefier diode than the one that was in there. I think these little MILF, that's MELF, not MILF. These are called MELF packages. But the MILF package is something completely different, but much more entertaining. Yeah, so it'll fit just about. I can solder it onto there, and yeah, let's see. That fixes a. Apply some heat. My arms are going to be all over the place. To hold the component close, because I'm melting the board, but you've also got to preheat the component, otherwise a component with a bit of metal in like this will just suck the heat out the solder joint. So I can see it changing colour. It's going shiny now. I put some flux on it already actually, and then I think that's melted. We just drop that on. You see what the problem is? Slightly, I want to leave it like that, but there we go. Underneath that it's scorching there as well. These boards are most power supply manufacturers seem to do it. Those little red dots you can see under here, you can see the edges of red dots under these components, just there and there. That is epoxy, which is used to glue these components in place. So the surface mount placement machine puts a spot of glue under every component and then places the component on top, and that epoxy the component onto the board, and so then what they can do is they have the board with all the components glued underneath. Actually, when you're taking an IC off, it's quite difficult sometimes to break the epoxy. It's very good stuff, but you've got the components on the bottom, and you drop your through mount components from the top, so the transformer pins and the choke pins and all the other components that come through are plonked on, held down by gravity, and then this board will then go through. This side will be downwards with all the components hanging down, and it goes through a wave solder machine, and it's a big wave of solder, big molten bath of solder with a pump, which then a wave is blasted across here and it goes over this wave. Imagine the crest of a wave with solder flowing, and then this goes over it and solders all the joints and all the surface mount components. It's quite difficult to believe that you don't get bridging and stuff like that, but the thing is very hot and the surface tension of the solder is quite good, and of course the wave is moving, so you don't get a lot of excess unless the board is actually too cold. And then with wave soldering, it also enables them to leave tracks blank. For example, these tracks have no etch resist on them, or no solder resist on them, should I say, and they just leave them blank, so that before this goes through, these will just be copper, and then they put them through the wave soldering machine and you get a beefed up track. So the current capability of these tracks can be increased by putting this solder on. Although I don't see it makes any difference with this at all, because the designer has done that. But look, all this is copper anyway, so this is pointless, and so is that actually. But you know, it's something that they've learned from somewhere, but didn't fully understand what they were doing. But it's anyway, the diode's in. It's not that pretty. It's not sitting pretty because there's a little bit of epoxy underneath, but it's soldered. It's firmly soldered both ends. So let's go off totally macro. And then see what we've got on our bootstrap supply and see whether that's fixed the problem. There's your problem. Okay. Get this arranged correctly so you can see it. There we go. So power on, plug it in. Is it working? Yeah, it's working, all the lights are on, so it's working now. So remembering this side's okay because this is isolated, I can touch that, but I won't be touching that side. So let's put it on 20 volts. Let's check the bootstrap supply now across the Zener. The Zener is regulating the bootstrap supply, you recall. And now we've got, yeah, so it's probably a 17 volt Zener. We've got 17.7 volts. Remember we had about 10 or 11 volts before, so now it is running from the supply. So it's from the transformer through that resistor, through this diode, and onto there. And there's enough, this diode's a little bit higher. Oh no, there's other diodes the same size, so we're fine. Okay, so we've got Schottky, 2 amp Schottky diode in there, so that won't go wrong again on that part. So I'm going to put it back together, and that really concludes the repair. So if yours has got the same sort of problem, completely dead, it might just be that diode. And you can see putting a 5p diode in can save you having to buy another 20 quid battery charger. So thanks very much for watching.